Good morning, dear students. In today's class, we discuss regression analysis. What is this regression analysis? It is a continuation part of correlation, I can say, because here by using the correlation theory, that is by identifying the degree of correlation between two variables, two interdependent variables, we can estimate future values. For example, we all know that there is a correlation between rainfall and crops. How rain increases, we can get more crop also. If the size of rain is more, the crop size will be more. So here there exists a positive correlation between rainfall and crop in the agri field. So by using this relation, we can estimate for how much quantity of rain, how much quantity one can produce. This is what we study in regression analysis. So in regression analysis, first if we come regression, literally it means return to the origin or stepping back towards the average. So here we are going back to our average value. By using the relation, we are describing tendency to regress or step back. Okay, that is called what? Regression line. Tendency to regress or step back is called regression line. So here we can estimate with a fair amount of accuracy the position of this line. So it is also called as the estimating line here. So regression line, if you plot the values in the graph sheet using the correlation, that is average, we can estimate the other values. So what is the change in, by considering the change in one variable, what would be the change in another variable? That already we draw a scatter diagram in correlation chapter. Okay, so like that, if you draw a line here, regression line, using that line we can say what would be the value for other variable. Then this is also called as what? Estimating line. The term regression was first used by the British biometrician Sir Francis Galton. So he is the person who introduced this term regression. So it connection with the inheritance of stature. Galton found that the offspring of abnormally tall or short parents tend to regress or step back to average population height. But the term regression also now used to statistics is only convenient term without having any reference to biometry. So that means here Sir Francis Galton, he has used this term for in the biofield he has used. So measuring the height of the parents. So based on the height of the parent, what would be the height of their children in future? So here now this term is not only used in biometry but also it is used in statistics. And here the two variables are correlated, means the unknown value of one of the variable can be estimated by using the known value of the other variable. So here when one value we know, value of one variable we know, for that another dependent variable we can estimate. That is, if rainfall is 10 mm, in the agri field we are producing 1 ton crop. If rainfall increases to 15 mm, then we are producing 2-ton crop. Then what would be the rainfall if you want to produce 5 ton? So that we can estimate. Or even we can estimate if rainfall is 50 mm, what would be the production? So this is how we use this regression theory here. For one variable, we identify another variable. So here properties of tendency of actual value to lie close to the estimated value is called regression. So here the property of tendency of actual value. So actual value here whenever we estimate certain values using regression theory here, so if we find the actual value, it is almost near to the estimated value here with help of regression. So that is called is what here? Regression. In wider uses, regression is the theory of estimation of unknown value of a variable with the help of known value of the variable. So here when two values are interdependent on each other, for one variable we are identifying another variable, assuming that one is dependent on another. So with help of one variable we are estimating the value of another variable. Okay, so here mathematical measure of average relationship between two or more variables is termed terms of original units of the data. It is a statistical device with the help of which we are in a position to estimate or predict the unknown value of the one variable from a known value of another variable. So here we are we are estimating or predicting one variable with the help of another known variable. And here certain terms which we should know. So first, that is regressor or predictor. What is this regressor? So here in regression analysis, the independent variable is known as regressor or predictor. For example, I know rainfall 50 ml, 50 milliliter rainfall is coming. For that, how much crop can be grown? So here known value is what here? Rainfall. So rainfall we can say it is independent value, that is predictor or regressor. So with help of which we are identifying here? How much crop we can produce in agri field. That we can refer as a regressed or explained. So independent value is a regressor, predictor or explanator, and the dependent variable which we are going to identify, that is termed as regressed or explained variable. And a few more terms here we should know. The points in the scatter. Already we draw a scatter diagram in the correlation chapter. If the variable in a bivariate data are correlated, if they have any correlation, either it may be positive or negative or whatever, we may find that the points in the scatter diagram will cluster in the form of a curve or in the form of a straight line. So either we get a straight line or a curvy line. Okay. Then in the former case, it is known as curve of regression. If you have a curvy line in a correlation scatter diagram, that is termed as curvy regression. And if it is a straight line, if you are getting a straight line, then we term that as a line of regression. So when two variables are said to have a linear relation with when the change in the variable of the independent variable by 1 unit leads to the constant and absolute change in the value of other dependent variable. So here two variables have linear relationship, we say, that is it may be positive or it may be negative. A unit change in one variable leads to equal or opposite reaction in other variable, that is equal change in other variable in the same proportion every time. And here when the two variables have linear relationship, the regression equations can be used to find out the value of the dependent variable. So when here two variables have linear relationship, that is change in one unit leads to change in another unit, then we can find the value, that is for known value we can find unknown value with the help of the regression equations. Here we can write the equation and we can find, and for that certain things we should assume here. Okay, we should assume that one variable is dependent on another variable. So what is that here? In the line regression, so the line of regression is the line which gives the best estimate to the value of one variable for any specific value of the other variable here. That is, when we have here line regression line we prepare here, okay, one line of regression which gives best estimate for unknown value with help of a known value here. For specific value, if you give for that specific value, it will give value for unknown variable or dependent variable here, and here thus that estimated value is accurate, almost it is equal to the actual value, so it is called as what here, best line of best fit. So thus line of regression is the line of best fit and is obtained by the principle of least squares. So least squares, with help of that principle we estimate here line of regression. So here for a bivariate data x on y, x and y, so we can prepare two regression equations here. So first one, assuming that x is dependent on y and assuming y is dependent on x here. So 2, because when x is dependent on y means x value we identify for a known value of y, and when y is dependent on x we estimate value of y when we know the value of x here. So x on y and y on x, two regression line we get here. So first here it is given equation obtained with the assumption that x is dependent on y and is called the regression equation of x on y. When we assume that x is dependent on y, it is called as x on y. So we can read it also as a x on y means x is dependent on y variable, and this equation is called as x minus x bar is equal to bxy into bracket y minus y bar. So that is bxy is called as a regression coefficient, and later we will speak about that. So x minus x bar, x value to be identified minus x bar, average of that value, is equal to bxy into bracket y, the known value of y minus its average y bar. Then another variable where we assume that y is dependent on x, and that regression line is called as regression equation called as y on x. We can read it also as a y is dependent on x variable. The regression equation of y on x is called as y minus y bar is equal to byx into bracket x minus x bar. So here y is the value which is to be identified, minus y bar is equal to byx, that is regression coefficient, into bracket x, the value of the known value with help of which we can identify value of y here, minus x bar, average of x values. So here as I said, bxy and byx, these are two regression coefficients, and the value of these two coefficients are totally different, and even the formula to identify bxy and byx is totally different. So what are the formulas to find them, so that we can find here. So here regression equation x on y is used to find the estimation of value of x here, and regression equation y on x is used to find the estimated value of y variables here. Next, to formulas of regression coefficients. Okay, so here bxy, its formula, simple formula if you refer here, that is r into sigma x divided by sigma y. R is nothing but here Karl Pearson's coefficient of correlation value. So correlation into sigma x divided by sigma y, that is formula to find bxy coefficient. And for byx coefficient, it's again correlation r into sigma y divided by sigma x. Then if you write the formula to find that then n summation xy minus summation x into summation y whole divided by n summation x square summation y square minus summation y whole square. And equation for byx is n summation xy minus summation x into summation y divided by n summation x square minus summation x whole square. So if you refer that formula carefully, then it is almost similar to the formula of correlation, where denominator part is taken half, not full, and numerator part is as same as correlation formula. Then for grouped data, again it is also again same as a correlation formula, n summation of summation xy fxy into bracket x summation fx into y summation fy divided by n summation y square fy minus summation y fy whole square. And for byx equation, n summation of summation xy fxy minus summation x fx into summation y fy divided by n summation x square fx minus summation x fx whole square. So here already we discussed those formula. Without wasting much time, we proceed further. Now properties of regression coefficient. So here like correlation regression, correlation we have properties. For regression also we have certain properties which are to be studied thoroughly here. So first property is what it tells. The regression coefficient bxy is the change occurring in x for unit change in y. So this bxy tells that how much change taking place in the unit of x for a change in unit y. That is said by what bxy, and vice versa. Byx tells that what is the change takes place in y depending on the unit change in a variable x. And second, regression coefficients are independent of change of origin but not of scale. What is this here? So correlation, there both correlation is independent of change of origin as well as a scale. So here in regression analysis is independent of change of origin but not of scale. Means if we add or deduct any value to all the variables, that doesn't affect our bxy and byx values. The values will remain same if we calculate them directly. Suppose if we divide or multiply all the variables with help of any constant value, then it changes our coefficients values. That means we don't get accurate answer here. And third property here, geometric mean of bxy and byx, both coefficients. Geometric mean of both the regression coefficients is nothing but here correlation. And for that we can say here, if bxy is positive, byx will also be positive. If bxy is negative, byx also will be negative. That means we get both positive or both negative. One positive, one negative we don't get. If such thing comes, that means somewhere we made a mistake. So why is that so? Because here if you refer the formula, numerator part is the same for both the formula, only denominator part is changing. So if once for bxy we get a positive answer, means for byx also we get a positive answer itself. So if both coefficients are positive, then we get a positive correlation. There is a positive correlation between x and y. And if both regression equations are negative, it indicates that the x and y variables have a negative correlation. Okay, so based on this relation we have certain formulas here. So bxy is equal to then r into sigma x divided by sigma y, and byx is equal to r into sigma y divided by sigma x, that already we learned. And bxy into byx is equal to r sigma x divided by sigma y into bracket r sigma y divided by sigma x. Next, here by referring that here bxy into byx is equal to r square. That means r is equal to plus or minus root of bxy and byx, that is geometric mean. And here next, since the coefficient of correlation numerically cannot be greater than 1, that means here the product of regression coefficients cannot be greater than 1. Though maybe one regression coefficient we may get the value more than 1, but another variable will be less than 1. That means the product of both the regression coefficient is less than 1 always. And next property is the two regression coefficients cannot be of opposite signs. That already I said, they both will be either positive or negative. They don't come of both the sign. Okay, then certain notes here. If r is positive, then both regression coefficient will be positive. If r is negative, both regression coefficients will be negative. If r is 0, then both the regression coefficients will be 0. Both the regression coefficients will be 0. Next, here we have certain properties of regression lines. What we learn now is properties of regression coefficients. Now, properties of regression line. So first one, the two regression lines intersect at x bar and y bar. So when we draw regression lines in a graph, so both will intersect. That means both will touch each other where mean of both the variables exist. That is, suppose we draw a regression line x on y, and suppose this is a y on x. Wherever they are touching, here we get both y bar and x bar, the mean of both variables we get there. And second, if there is a perfect correlation, the regression lines coincide, there will be only one line. That is, if either it may be negative correlation or maybe positive correlation. So in such cases, we don't get two lines here, both will be coinciding, so we get only one line. It may be in any direction. Okay, and when correlation does not exist, that is r is 0, two regression lines are perpendicular to each other. Perpendicular means here, so they are perpendicular to each other. Next, use of regression analysis. Where all we can use? So here we can use regression analysis in estimating a functional relationship between two or more variables. To estimate the functional relationship, and regression analysis provides an estimated value of the dependent variable for a given value of a independent variable. If any independent variable is given, for that we can find dependent variable. Next, second one is, with the help of regression coefficients, we can calculate the correlation coefficients, which measure the degree of correlation that exists between the variable. So with help of both the coefficients, we can estimate what here? Correlation, and we can say what is the degree of correlation between the variables. Then regression analysis is widely used in statistical estimation of the demand curves, supply curves, production function, cost functions, consumption functions, etc. So these are used in economics subject. So in economics we find all these curves, demand curve, supply curve and all. So in producing and estimating these curves here, regression analysis helps. Then what is the difference between correlation and regression analysis? So first, correlation analysis deals with the association between two or more variables. Just it deals what is the association, it tells degree of relation here, whereas regression analysis is concerned with the derivation of an appropriate functional relationship between the variable. So it tells the degree of correlation and it tells appropriate relation between the variables. Then correlation need not imply cause and effect relationship between the variable under study, and regression analysis clearly indicates the cause and effect relation here. So correlation just it tells whether it is positive or negative. It doesn't go through what is the cause and what is the effect. But in regression analysis, it would say what is the cause and what is the effect. So cause in one variable, it affects in another variable. Then third point is there may be a nonsense correlation between two variables which is purely due to chance and has no practical relevance. So here nonsense correlation means there is no correlation at all, we can say in correlation, but in regression we cannot say there is a nonsense regression. Here there is no such things. And in a correlation, Rxy and Ryx are symmetric. If we interchange the variable, if we find Rxy and interchange the variable, and if we find Ryx, both values will be remain same. It tells the same. But in regression analysis, Bxy and Byx are not symmetric. So we get totally two different values here. And next, correlation coefficient is independent of change of scale and origin, both here. Correlation coefficient, it is independent of both scale and change origin. But whereas regression coefficient, it is independent of change of origin but not of scale. So in correlation, we can deduct or add any constant value to all the variables, and also we can divide or multiply any constant value to all the variables, but not in case of regression analysis. Only we can add or deduct any constant value to all the variables, but not multiplication or division. Okay, so this is all about theory part of our regression analysis. So in our next class, we solve some problem on regression analysis. Using the regression equations, we estimate for unknown value with help of a known value of the other variable.